Hi my dear students, how are you now? This is the fifth video of the series of matrices and determinants. In the fourth video, we did few important very short answer problems on determinants using properties. Now let us continue the remaining problems in this video. Most important questions which appeared in the board examinations many number of times and expected questions going to come in next examination are going to be discussed in this video. So please pay attention, and if you have any doubts, please feel free to give your comments in the comment box so that I can clarify them in the coming videos. Look at this determinant. Result is a minus 1 cube. As I said in the last video, whenever a determinant is given, you are lucky enough that answer also will be given. You have to get that answer. It is not that find the value. Result will be given to you. So RHS will be there with you. Now how to get the RHS? As I said, there are two ways. One is try to get this as a common factor from any row or column using elementary row or column operations which are valid in determinant. Addition of rows, subtraction of rows, R1 plus 2 R2, C1 plus 2 C2, like this. Think so that a minus 1 can be taken as a common factor. If you are not able to think how to get this as a common factor, then simply try to make two zeros. That is the best. Getting common factors by subtraction, this definitely you will get if you practice more number of questions. Otherwise, the final remedy is try to make two zeros along a row or column. For that, you have to get three equal values. 1, 1, 1. Already three equal values are there. Three equal values are already with us. So R1 is going to be changed as R1 minus R2. In the process of getting two zeros, unknowingly, without your knowledge, you will get these common factors. That is the advantage of this step. Now, a square plus 2a minus 2a minus 1. 2a plus 1 minus a minus 2. 1 minus 1. R2 minus R3, 2a plus 1 minus 3, a plus 2 minus 3, 1 minus 1, 3, 3, 1. So I am planning only to get two zeros. I never thought of making a minus 1 common factor possibilities. I am concentrating only on getting two zeros. See what is happening. 2a gets cancelled. A square minus 1. A square minus 1 is a minus 1 a plus 1 using a square minus b square formula. 2a minus a and 1 minus 2 is minus 1. 2a plus 1 minus 3 is 2a minus 2. This is a minus 1, 3, 3, 1. See a minus 1 common factor. Here I can take 2 common. So it will become a minus 1. I will write here a minus 1, a plus 1, a minus 1, 0, 2 common, a minus 1, 0, 3, 3, 1. A minus 1 common from the first row, a minus 1 common from the second row. Then I left with 1, not 1, it is a plus 1, 1, 0, 2, this is 1, 0, 3, 3, 1. So a minus 1 square into, I would like to expand along third column. 0 into cofactor, 0 into cofactor, 1 into cofactor. So try to expand the determinant only along a row or column in which two zeros are available. Then it never comes under expansion. It is nothing but finding one cofactor which is allowed. So 1 into plus minus plus, so 1 into a plus 1 minus 2. A plus 1 minus 2 will be a minus 1. A minus 1 square into a minus 1 will become a minus 1 cube. That's the answer. So here I never thought of getting a minus 1 as a common factor. You can think in that direction also, like we did. Difference will give a minus 1 here. Or R2 minus R3 also will give a minus 1. So many number of ways are there to get the solution. So whichever you feel comfortable, whichever is easy for you, you can follow that. There is no restriction. The final remedy is when it is not possible to think about common factors, try to get zeros. 2 zeros along a row or column will make things simple and easy. Okay, I hope it is clear to you. Let us move to the one more important short answer or long answer problem based on the board, because some questions which came in CBSE for 4 marks, they appeared in AP and Telangana state for 6 marks problems or 7 mark problems. Look at this determinant. What I am supposed to get? A plus B plus C cube is asking to get this result. Very different. A minus B minus C, then 2A repeated twice, then 2B, B minus C, then 2B, 2C, 2C, C minus A minus B. Principal diagonal is different and remaining are 2 times of this. So how to get? Now here getting 2 zeros, not possible. It's not possible. What I mean to say, 3 equal values are not directly shown here. So don't think to make 2 zeros in the beginning itself because 3 equal values are not found. Then what to do? Then the first method. To get A plus B plus C as a common factor, A plus B plus C whole cube means is a product of A plus B plus C thrice. Try to get at least one A plus B plus C as a common factor. To get A plus B plus C, we should have A plus B plus C in the determinant available. I have A minus B minus C. Here I have 2A. If 2A is added to this, 3A, but I don't want 3A. 2B is here. If 2B is added to this, become plus B. I need A plus B. If 2C is added, I will get C. So if 2B and 2C added to this, I will get A plus B plus C. So what I am going to do is, first row is added with second row and third row. So all rows are added like this. It will become A minus B minus C, 2B plus 2C. So that is going to become A plus B plus C directly in the next step. 2C will be added to this and this added to this. So again I will get A plus B plus C, A plus B plus C. 2B minus B, 2A minus A. So all will give A plus B plus C. Remaining are unaltered. So A plus B plus C, A plus B plus C. Now A plus B plus C is taken common. 1, 1, 1. 2B, B minus C minus A. 2B, 2C, 2C, C minus A minus B. Then what happens? A plus B plus C. 3 equal values I got. When 3 equal values I got, I can make them 2 zeros. Now that final remedy you can use here. C3 minus C2, 1 minus 1, 0. 2B minus of this. 2B minus B will become B. 2B minus of minus C will become C. 2B minus of minus A plus A. Whenever you are subtracting 2 terms and the second term contains minus signs, so minus of minus, that care has to be taken. Calculations are very important. Even a plus minus sign is enough to spoil the whole solution. C minus A minus B minus 2C. So C minus 2C minus C minus A minus B. Similarly, C2 minus C1. 1 minus 1, 0. This minus 2B. B is there, minus 2B will give minus B minus C minus C. 2C minus 2C will give 0. 1, 2B, 2C. We can expand along the first column. No, not column. along first row like this, 1 0 0. So what happens to this? 1 into this multiplication. If I take minus common, a plus b plus c, a plus b plus c, a plus b plus c whole square. 0 into this will be no more. So the result is going to be a plus b plus c into a plus b plus c whole square minus 0. That gives a plus b plus c whole cube. So though it looks very odd and unusual in the beginning, by looking at the answer, if you think how to take a plus b plus c from the determinant using properties, once you get the idea, if you crack the idea, then easily you can go for a solution. Try to take the common factor. Once you got the common factor, you will get 3 equal values, make them zeros, then expand along a row or column in which 2 zeros are present. One more important. Show that this determinant equal to twice this determinant. So here a determinant is again as a determinant we have to prove. This determinant equal to twice into another determinant, this we have to prove. If it is a product of some factors, I can go for row operations, subtraction, addition. But here again a determinant I am supposed to get. So how to do this? This 2 is there. This 2 will give the idea what to be done. Add all the columns which gives b plus c, c plus c, a plus b. So b repeated, a repeated, c repeated. So 2 into a plus b plus c I am getting there. C plus a plus b, b plus c plus c, a plus b, c plus b, a plus b plus c, a plus b. See here, after a plus b we should have b plus a, then we should have c plus. This is reasoning. B plus c plus a plus b. Then again symmetric matrix, c plus a plus b, b plus c, then a plus b, b plus c, c plus a. So there is a correction here. B plus c, a plus b, b plus c, c plus c. Let me take 2 common. I can take a plus b plus c also, but that is not required. So I am taking only 2 common. A plus b plus c, b plus c, c plus a plus b plus c, c plus a plus b, b plus c, a plus b, b plus c, c plus a. Now what I am going to do? This is the most important step. I need a, b, c. This is a complicated term, leave it. I have c plus a, but I need b only. C plus a, I don't want c plus a, I want b here. So c2 minus c1. If I subtract, what happens? C plus a minus of this will give minus b. A plus b minus of this minus c. B plus c minus of this minus a. Similarly c3 minus c1. A plus b minus of this minus c minus a minus b, and this as it is. So c2 minus c1, c3 minus c1, I got this, but I don't want minus there. Of course minus available in the whole column, so I can take minus common. Before that, what I am going to do is this minus b and minus c, both the columns I want to add to the first column again. The same operation I want to perform again. Why? C1 plus C2 plus C3. Because minus B comes here, minus C comes here, it becomes A. Minus A added become B. Minus A minus B added becomes C. Minus B minus C minus A minus C minus A minus B. Then minus common from this, minus common from this. Pay attention, minus common from both the columns, here and here. In one row, if a common factor is available, you can take common. B, C, A, C, A, B. So this become 2 into A, B, C, B, C, A, C, A, B. That's the answer. So this you can expect for long answer questions or short answer question based on the board, as I said. So I need answer as again a determinant, not as a factors. 2 into determinant. The best thing or the only thing what I can do is I can take 2 common by addition of all columns. You can do addition of rows also. Because of the space constraints what I have on my board, I have went for column operations, and column operations will save the space. That is the only reason I follow. You might have seen the last questions also. I prefer to go for column operations just to save the space. That is the only reason. Whatever the column operations we are doing, you can try for row operations also. Makes no difference. Based on the availability of the common factors, whichever can be done, that operation you have to follow. So you can go for row operation also. Makes no difference. We will get the same answer here in this question. So all columns are added. I have taken 2 common, then C2 minus C1, C3 minus C1 was done to get the answer almost same except the minus sign, and again added this to get rid of the unwanted terms. Then I got the solution. This is also one of the important questions. A, B, C, they are not equal to each other and none of them are zeros. If determinant A square A cube plus 1, B square B cube plus 1, C square C cube plus 1 is becoming 0, then prove that ABC plus 1 equal to 0, or prove that ABC equal to minus 1, or find the value of ABC which is equal to minus 1 we have to get. So this is also one of the important question. As I said, this also repeated question in the board examinations. Here I am going to use the last property discussed in the properties of determinants. If one column or one row is the addition of 2 numbers, then the whole determinant can be expressed as a sum of 2 different determinants. So this can be expressed like this: A square A cube, B square B cube, C square C cube plus A square 1, B square 1, C square 1, that is 0. So first elements in this determinant, next elements in the other determinant. In the first row, A can be taken as a common factor, second row B, third row C. So 1 A square, 1 B square, 1 C square plus. You look at this determinant, columns are same but the positions are different. The first column is the second column here. So what I am trying is, I am trying to get the same determinant here if possible. For that I need 1 in the beginning. So interchanging 2 columns. 2 columns are interchanged. When two columns are interchanged, two rows are interchanged, then the determinant changes its sign, minus sign is going to come. Still this and this are not equal, only one column is made equal. Again these two I am going to change because I want this to be same. Equal to 0. 1a, a square, 1b, b square, 1c, c square. Let this is delta. And this is not going to be 0 because they are not equal to zeros. A is not equal to 0, B is not equal to 0, and A, B, C are not equal. If A, B, C are equal, then two rows equal become 0, but that is not the case. Clearly given that the determinant is not equal to 0, indirectly it is given. It is not equal to 0. So this whole determinant not equal to 0, I can take it as delta. So A, B, C delta, minus into minus plus, delta equal to 0. So A, B, C plus 1 by taking delta as a common factor. Delta not equal to 0, it is explained here. When delta not equal to 0, the left out thing is ABC plus 1, 0. So ABC equal to minus 1. ABC equal to minus 1. So this is the proof or the solution of this. So very important question. We are using this property first time in my video. This is the first time we are using property where one column or one row is addition of two numbers. We can make two separate determinants. So see, most important thing is there are many questions in the textbook, reference books, additional problems. Doing each and every question in the video is not possible. So if you have any doubt, you can mention the problem in the comment box, so that I will give the solution in the next video. The main motto of this video is to highlight the most important board examination problems and to get an idea to the student that which type of questions are going to be asked in the examination. How to use the properties wisely. Skill, knowledge, logic, all these together should be applied to get the solution. Many problems are there. I am not going to each and every question because it takes hours and hours if you want to complete. So most important questions, selected questions of the CBSE and other textbooks I have taken and I have given the solutions. If you have any doubts, feel free to mention in the comment box so that we will discuss in the next class. So most of the important models I have tried to cover in this video. In the next video, if you want any other questions to be done, we will definitely going to discuss in the next video. That may be the last video on the matrices series. The 6th video is going to come soon. There we discuss about adjoint of a matrix, solving the equations by using matrix method, Cramer's method, Gauss-Jordan method. All these methods we are going to discuss. That will be very interesting, and we will meet in the next video as early as possible. I hope this video is very helpful to you. Please try to subscribe this channel, and as I said, please share to the maximum number of students so that they will get the benefit before they go to the board examinations. So matrices is a very important chapter, a very big chapter. So pay attention, try to score full marks. That's why I have done more videos on matrices so that all students should get the maximum benefit from these videos. Okay, see you in the next video.